Assalamualaikum. My name is Muhammad Firdaus bin Suparti, and Fakulun Najwan bin Ibrahim, which is my friend, we are going to present about our group project. So the title of our project is Technical Report of Tensile Testing and Microstructural Analysis for Enhancements of Aluminum Alloy 6061 by Recycling. I am going to present abstract, introduction, and methodology. The other three will be presented by my friend, which is discussion, conclusions and recommendations, and reference. So I am start with abstract. For case study, the popularity of aluminum alloy has increased due to its outstanding properties. However, increasing in its applications also increase its production. Its production requires high cost and emissions of considerable amount of carbon dioxide to surrounding. Thus, its applications can be enhanced by recycling. Recycling reduces the cost and minimize emissions of carbon dioxide and offer for sustainable alternative. So the aim of our project is to evaluate the relevancies of adopting recycled AS061 as enhancements of primary AS061 by comparing their damage and properties in terms of development of the damage. So the method is first UNIAXIAL tensile testing, which will be follow ISO 6892 number 1 and ASTM EAM21. And the second one is SDM, which is energy dispersive spectroscopy, which will follow ASTM E1508-12A. For result, so the UNIAXIAL tensile testing shows that the recycled AS061 exhibit extremely identical tensile properties to its primary alloy, while for the energy dispersive spectroscopy, the finding shows that the recycled AS061 display almost identical element composition to its primary alloy. As for overall conclusions, the finding shows that the enhancements of primary AS061 by adopting recycled AS061 is proven as relevant. This is because it exhibits comparable outstanding properties and better in terms of sustainability compared to the primary AS061. Now, I am going to present about the introductions. So, the applications of aluminum alloy has boosted progressively. Energy usage and emissions of carbon dioxide also increase due to increase in its productions. And then, the effective enhancements on aluminum alloy by recycling is proposed. So, aluminum alloy exhibits excellent recyclability, which means that it retains all its primary properties. And then, direct recycling involves sequence of heat treatment such as hot fogging press, quenching, and aging. Some research depicts that heat treatment during recycling enhances tensile and compressive properties of the recycled aluminum alloy. Thus, UNIAXIAL tensile testing and EDS are proposed to test this product enhancement. Next, let's move to the methodology of this project. So, in this project, there are three steps, which is sample preparation, tensile testing, and microstructural analysis. So, the first step is sample preparation. So in this project, there are two samples need to be prepared, which is primary AS6061 and its recycled version. So for the first sample, the primary AS6061 only need two steps of preparation, which is sheet sectioning and finishing. So this sample is finished into doped bond shape. For the second sample, which is recycled AS6061, it requires 7 steps of preparation. First, the chip is produced, and then the chip is cleaning with ultrasonic bed tube, which is immersion in acetone solution, and then the cleaned chips will be dried in thermal oven at 60 degrees Celsius. After drying, the chip is undergoing hot press fogging. So the temperature is 530 degrees Celsius, the pressure is 47 millipascal, and the duration is 2 hours. And then, after hot press fogging, the chips is undergo quenching at rate 100 degrees Celsius per second, and then aging in thermal oven at temperature of 175 degrees Celsius for 2 hours, and the last step is finishing. So this sample also finished into a doped bond shape. So the current slide shows the standard doped bond tensile shape for rectangular flat sheet according to ISO 6892 number 1. So the parameter and the dimensions is given according to the standard. So the gauge length is 25 mm, the width is 6 mm, thickness is 1 mm, radius of fillet is 6 mm, overall length is 100 mm, length of radius sections is 32 mm, length of grip section is 30 mm, and width of grip section is 10 mm. Okay, now I am going to talk about the second step in the methodology, which is tensile testing. So tensile testing have 7 steps. The first step is preparation of test machine. So make sure normal operating conditions to avoid error during operating. And then second one is measurement of dimensions of the specimen. So to total cross-sectional area must be measured in the beginning. And the third step is gauge length marking of the specimen. So this step is done by referring to the specifications of material used. And then the fourth step is zeroing of test machine to ensure no preload before the test start. And then the fifth one is gripping of the specimen. So it needs proper alignment, centered and parallel with test direction. And the sixth one is setting of speed of testing. So this speed of testing is depend on this thing, which is strand rate, stress rate, cross-head speed, elapsed time, free running cross-head speed. And the last step is run the testing. So the machine will read the extensions and load applied by the machine. The last step in the methodology is microstructure analysis by using EDS. So the analysis starts with adjust operating conditions to maximize X-ray count rate at highest possible accelerating voltage. This is to avoid damage at beam sensitive specimen. Next, collect spectrum from large area using large probe in optimized period, which is 4 to 6 hours depending on sample composition. Next step is assign peak, and then assign most instance peak. So during this step, pathological overlaps may occur and should be deconvoluted. So repeat these two steps until observed peak identified, and then the data can be analyzed.
Hi, my name is Fakun Najam bin Ibrahim. My matric number AD108200. Now I will continue about the discussion part. In the discussion part, it can divide it into the 5 subtopics. And the first subtopic is the test method of the tensile testing. One of the critical steps in tensile testing is the testing of the speed. From this current testing, we will adapt tensile speed based on the standard of the material. As we can see in the table show, the loading speed in unit mm per minute and the strain in S-1. The loading speed according to the table, tensile mesting is done twice of the level speed and strain rate. Now we will move to the result of tensile testing. The data then is recorded and transferred to the Excel spreadsheet to calculate the value of the stress and strain. The test number is only given as the gradient. Actual number of tests is depend on the total number recorded by the machine. As we can see from the figure, from the table, the number, the time in unit second, the extension in unit mm, the load in unit n, the stress and the strain are tabulated in the one table. Next, we will move to the comparison of the stress strain. The result from the previous table are calculated using the equation 1 in equation 2 in introduction and been plotted. Note that the actual number of the stress and strain is depending on the actual value of the calculated. As we can see from the graph, stress strain stress versus strain, and the component is the AA061 and the recycle AA061 in strain rate 1 and the strain rate 2. And now the comparison of the tensile properties. Data analysis are made to determine the tensile properties, including the Young modulus, ultimate tensile, percentage elongation, and percentage area reduction. As we can see in the table show, the material and for the A6061 and the recycle A6061, and the component is the loading speed, the strain rate, the Young modulus, the yield stress, the ultimate tensile stress in unit MPa, the percentage elongation, and lastly the percentage reduction in analyzed in one table. The last part is the result of the microstructure. The result of the element of the composite AA6061 and recycle AA6061 displayed in table to make the comparison the plotted. The element of the both material are the copper, ferrum, magnesium, silicon, magnesium, cadmium, zinc, titanium, and alloy. And it test in the test and the percentage is GB. And after that we make the table. We make the graph to comparison of the between the both element in term of the density and KEV. Next is the conclusion part. Through this report, tensile testing and microstructure analysis were determined by using the ATM and STM respectively. Thus, we can conclude that for the enhancement of the primary AS061 by recycling an excellent discussion to adopt for AS061 more sustainable material. The aim of the project, which is to prepare the technical report on tensile and microstructure analysis, were achieved. And for the recommendation is the expanding importance such as cutting edge technology has been conclusively shown increased uses in the future research. Adding reinforcement material during the cycle process to provide better assessment, and thus suggest to evaluate and compare the damage and work between the two material to get better comparison and for thus more convenient result. Lastly is the reference, as we can see in the table, which is the title and the author and the date of the publication. That as phone apps. Thank you.